Okay, let's start. So using this simulation, I will demonstrate how you can measure the velocity of sound. Of course, we won't do it this way in real life, but this is just to understand the concept of what is meant by velocity of this sound wave, or any wave for that matter. Okay, so right now you can see some ripples moving through this screen. Actually, it's a visualization of a sound wave. Now, sound is a what type of wave? Longitudinal or transverse? Longitudinal. So it's a vibration of the air molecules. You saw in the previous animation, right? The air if sound is traveling in this direction from speaker to the ear, then the air molecules are also vibrating in the same direction. So the air molecule, if it is here, if this is the equilibrium position, then it vibrates from here till here and then from here till here. So this maximum distance which it moves from its equilibrium position to the extreme position is called as what is it called? No. Amplitude. So this is called amplitude. So please note this down. How can you not know this even after so many classes? Amplitude is the maximum displacement of each particle of the medium from its equilibrium position. So every particle will move from its equilibrium position to one extreme position and then back to equilibrium position, back to extreme position in the opposite direction.
So the amplitude is from the
equilibrium to
one
the extreme position.
To one extreme to the other extreme.
Equilibrium to one extreme. So this is another amplitude. So this will become 2 amplitude. Twice of amplitude. Okay? Now, number of times it makes these vibrations in 1 second is called as what quantity? Frequency. And the time taken for one complete oscillation from here to here to here to here, that time is called as time period. And frequency is related to time period as? How is frequency and time period related?
Higher the frequency.
Formula.
So,
don't know? Have I not done it? Okay, let us say 10 oscillations take, whatever 10 oscillations take, let us say 1 second. So this 1 second is called as, okay. So if 10 oscillations take 1 second, number of oscillations in 1 second is called as what quantity? Frequency. So this 10 oscillations represents frequency. Agreed? Because it tells you how many oscillations happen in 1 second. Now if you ask you, one oscillation will take how much time?
1/10.
The time taken for one oscillation is called as what quantity?
Time period.
Time period. So this time will be a time period, T. So how will you find T?
So 1/10.
So you just cross multiply T into 1. Oh sorry, time period you need, right? So 1 into
1/10.
1 into 1. Okay? 1 second into 1 oscillation divided by 10. And this 10 is actually 1 by F. Agreed? So time period is So time period is actually 1 by F. Do you get it now? Why time period is 1 by F? What's his name? What's his name? You are supposed to take notes when teaching.
Time period is the time an air molecule takes to complete one oscillation and get back to the equilibrium position.
Not necessarily equilibrium position, starting position. You can measure time period from any position, not necessarily only from the equilibrium position. Okay? Okay. Now we want to go on to velocity. So velocity, there are two types of velocity in a wave. One is the wave velocity, another is the particle velocity. You need to know clearly which velocity you are talking about. So if you look at the sound wave right now, each air molecule is moving like this, right? It moves very fast, like this. Agreed? So there is the velocity of the particle. but that is not the velocity of the wave. You getting what I'm saying? Velocity of the particle keeps changing. At the equilibrium position, it will be maximum or minimum. If the air molecule is vibrating like this, it's moving very fast. The speed of the air molecule is maximum or minimum at the equilibrium position?
Maximum.
Maximum. And then it slows down, comes to rest here. So it becomes 0. Then it changes direction, becomes maximum in the opposite direction. Slows down, comes to rest here. Like this, its velocity of particle keeps changing direction and magnitude. Write it down. Velocity can be of particle, can be of wave. Particle velocity keeps changing both magnitude and direction. Okay? And what do you know about magnitude? When is it maximum? And when is it minimum? Maximum in which position? Sparsh Gandhi? Equilibrium position. When is it minimum? Gibson. When is the speed 0 for a particle? At which position? Extreme position. Very good. So now this is what you need to know about particle velocity. Now let's go down to wave velocity. Wave velocity means if I am standing at say 50 kilometers away and imagine my voice is loud enough to reach you from 50 kilometers. Okay? If I shout, Keshav, like that, you will hear it. Will you hear me instantly or it will take some time? Even thunder you have seen, right? You can see the lightning and after a fraction of a second then only you hear the thunder. Thunder takes more time to travel than light. Agreed? So, by timing how much time it takes before you can hear the thunder, after you see the lightning, you can estimate the distance of the lightning from you. Because you know the speed of sound through air. You get it? So, speed of sound wave refers to the distance traveled by the wave divided by the time taken. That's the logic. So, if no problem, media is there. Pause and get it back. Okay? So speed is distance traveled by wave. It makes sense, right? Just common sense. If you want to know speed of a wave, it should be distance traveled by time taken. You don't have to memorize anything in physics, it's all common sense. If you understand it, you will get it.
So is there any difference between speed and velocity?
Velocity refers to speed with direction. Okay? So now distance traveled by a wave, instead of keeping it random and arbitrary, we want to have a formula which we can use, right? So for a wave, when it travels, if it's the case of sound wave, you will have region of compression, rarefaction, compression, rarefaction, compression, like that, right? So in this space, sound has not yet reached. So if the sound wave reaches here, the ear of the person, this compression will reach the ear. Agreed? Agreed or not? Basically, these molecules are not moving till the ear. It's just that the air molecules which are already present near the ear, they start getting compressed and rarefied. Compressed and rarefied.
That means
when the wave reaches, yes, when the wave reaches the ear, the air molecules present near the ear start undergoing compression and rarefaction. Then we say that the wave has reached. Agreed? This is clear? Okay, I see 1, 2, 3, 4, 5, 6 heads lying down on the table. If you see your neighbor is lying down, kindly wake him up. I already told you the class is getting recorded. If you do any of these things, I need to point it out. It becomes an embarrassment. I don't have time to edit the videos. It will go on the web. So kindly follow the class rules. Sit straight. Do not lie down. Sit straight. You are supposed to take notes. Take notes.
I lost my keys, sir.
I don't want any excuses. Take a sheet of paper and take notes. Okay. So, if you want to measure the speed of sound, you can just track the movement of any compression and see how much time it takes to travel some distance. So, one easier way is, when we look at the wave as it travels through the space, through the medium, we can see that these compressions move together, right? You can see here, if you look at the white spots, or let's say black spots, these black lines, you just think of them as compressions, and the white lines are the rarefactions. So they are moving together, right? Now distance between any two compressions refers to what? What does it refer? No. Distance between two compressions, successive compression, wavelength. We define wavelength as lambda. That's it, look at the board. What? Any doubt you ask me, please? Who has a doubt?
This is the wavelength in which was the amplitude.
Amplitude is the distance traveled by each particle from its equilibrium position, maximum displacement. This is in the whole wave pattern. The shortest distance after which the wave pattern repeats itself. Sit straight. Shortest distance after which the wave pattern repeats itself is called wavelength. Agreed? So compression to compression. If I copy paste this, I will get the next pattern. If I copy paste this, I will get the next part of the wave. So this is the shortest distance after which I can get the wave pattern. Agreed? So if I note down this wavelength, basically the compression travelled by a distance of one wavelength, and the time taken by a wave to travel one wavelength is called as, it is given a name, time period. So it just happens that whatever time each particle of the medium takes to complete one oscillation, in that same time the entire wave pattern will move forward by one wavelength. It happens like that. Okay? So, for distance you can use wavelength, for time you can use time period. So you get V equals lambda by time period. But 1 by time period is what quantity?
1 by time period is
1 by time period is what quantity?
1 by frequency, 1 by time period.
1 by time period.
Frequency.
1 by time period is frequency. Because frequency is 1 by time period is 1 by frequency. So 1 by time period is frequency. So it becomes F lambda.
Sir, this is the velocity for
Of the wave.
Yeah, so how do you find the velocity of particle?
No need. It's beyond your scope right now. Okay? You won't learn that right now. So this is the wave velocity equation. V equals F lambda. So for solving problems, what we can do is V F lambda, like this you can draw visually. Okay?
So it's lambda.
Lambda is wavelength.
So I can understand how does when the molecules of the medium, when they travel complete one oscillation, at the same time the compression has moved by one wavelength, like how does that happen?
Okay, that will take a bit more explaining to do. Right now you just take it as a fact. Mathematically you will understand it. Now it's a bit difficult to understand. Just keep it as a pending fact to understand, put a question mark. In higher grades it will become clear. Or some other time I will explain. Okay, put a question mark next to it. Right now you just take my word that it is. Okay? Why is a more deeper question to understand. Okay, so the way you use this V equals F lambda formula in problems is, if they give you the velocity and for any two quantities they will give, find the third del R.
It's like speed distance, right?
Yeah, VDT, similar to that. So if you know frequency and if you know wavelength, velocity will be F into lambda. If you know velocity and wavelength, you need to find frequency. It's V by lambda. If you know velocity and frequency, you need to find wavelength. It's V by frequency. As simple as that. Clear? So now in this simulation, let's measure the velocity. We'll be finding. Try to write as I speak. No. You understood everything, right? Okay, let's measure it now. So it's a 500 Hz sound wave. So this is how the girl is able to hear it. Now we want to measure it. So let's put the 0 mark on the scale. Okay. You want to measure the velocity, right? So distance traveled by time taken. So we will just track and pause it. I'm starting the timer. Okay? I will move it one frame at a time. Wait. We will take the starting of the black edge. Okay? This is the starting of the black edge. Everybody agrees?
Yes. So timer to start.
Here the black edge is about to start. Agreed or not?
Yes. So where are you measuring it?
So now from this point, from the 0 position, the black edge of the first wave will start.
Yeah.
So we will see how long it takes to travel 5 meters. Okay? Till the end of the scale. So let me now start the timer. So all of you keep tracking. One of you come out, Keshav come out. Using the marker, you will keep tracing the edge of this black wave which comes out of it.
It's on YouTube now.
Okay? Come here like this. Okay, now we have to keep tracking the black edge. Have you tracked it till now? Wait, I'll demonstrate what I mean. Like this. Okay? Each time you pause, your arrow should get longer. So that we don't make a mess or mistake. Done? Okay. Next. Because sometimes we may get confused. Now. Now.
No.
Now. Exactly 5 meters. अरे तू गलत तो नहीं कर दिया? Is he correct?
So I'll do it.
Right? I am thinking that it will be 5. Okay, let this be the first try. According to Keshav, it has not reached. Okay, fine. Tell me when it reaches.
One.
It reached?
One.
Okay, so this is trial 1. Let us repeat this one 5 more times and take the mean. So,
I have understand.
velocity is 5 meters divided by 0.0151. Distance by time.
FB about.
You don't have F here.
No F now.
Velocity is distance by time. Listen, please. Okay. So anybody has calculator? Get a calculator, hurry up.
So Google पे calculator लिखो.
So till then we can take other measurements.
Yeah. So please get the calculator. No? My phone is recording. Okay, next. You come out. Tell me your name.
So he's the smartest kid in our class. So he got it like.
I want someone to track it. Yeah, come. Tell your name again. Yuvraj. Calculate and tell me it's it. Okay, ready? No, not go back. Tell me when the next blank is about to start. No, it's the starting, right?
No.
Okay, now I'm starting it. Keep tracking. It has reached to
This guy was not professional.
2, 3,
Calculator.
4, 5.
Yes, sir. So हल्का सा और आगे. हल्का सा और आगे.
Okay, so
see
we are
my-
correct.
So my
That's
reading was
correct.
right, sir.
Very good. I got confused last time. Okay, what is the value?
Not calculated.
5 divided by 0.0151.
The calculator.
It was the exact
Oh, how to change that mode? Okay, take it away. Anyone has a different calculator or something?
Sir, Google. So this is the typical speed of sound in air. Are you getting it? So how do you know this is the typical speed?
How do I know means people have measured it? You can also measure it. We can do an activity.
Sir, I fixed it. So, but wouldn't it vary with the amplitude and frequency?
That's why, no. Speed of any wave, please note down, speed of a wave depends on properties of the medium. Okay, thank you.
And so, like with all waves of sound, whether like they have different frequencies or different amplitudes, will they have the same speed?
Yes, a particular medium of certain properties.
It can differ.
Listen, in the same medium, all sounds travel with the same speed. Okay? Speed depends on the medium property. The two properties which determine the speed of a wave are elasticity and inertia. Note down.
Sir, what's up? Elasticity. Elasticity and inertia.
So, wave speed.
How to preserve friendship?
Elasticity and inertia.
What do you mean by these two quantities?
Yeah, I'll show you. So that means the wave speed does not depend on the source. So whether I create the sound in different ways by higher frequency, lower frequency, higher amplitude, lower amplitude, it does not affect the speed of the wave. What is his name?
Smith.
Huh? What is his name?
I've copied everything, sir.
What is your name?
Sir Krishna.
Krishmit. It's going in your report that you keep sleeping in my class.
Sir, we have done everything, sir.
Fine.
So what about doing it?
So you're saying that If you have written it, you can go to sleep. Wonderful. It's all going on record.
The speed of a wave does not depend on its frequency or amplitude.
Colin, tell your name. Your name. Don't I need to know all my students by name? Please do not lie down in class. Take your notes. Pick up your notebook.
I don't have to.
Take a sheet of paper.
So 15 minutes ago for a page, so you still have to do
Guys, this is going on record.
It's still not going to be a page.
Okay, so it depends only on the property of the medium. Now, somebody was asking me a question. What was the question?
So again, the speed of a wave doesn't depend on its frequency or amplitude.
Yes.
Does it depend on not depend on something else?
It depends only on the medium properties.
And how
That
does
means-
sound travel in solids and liquids?
Same logic. The particles of the solid or the liquid are made to vibrate longitudinally.
Solids and liquids also doesn't travel as a longitudinal wave.
Yes, sound is a longitudinal wave. It cannot produce transverse wave. Okay. Now, what we mean by elasticity is,
So what's inertia?
I am coming one by one. Elasticity is ability of substance to regain its original shape when the deforming force is removed. See, for example, if this rod is there and you want to know what is the elasticity of this rod, okay? If I bend it, okay? Wait, this is too stiff. Okay, let's look at this wire. Okay, look at this wire. Let's look at this wire, okay? Right now it is being pulled with some stiffness. Agreed? If I apply a deforming force, it's deformed. The shape is no longer a straight line. If I remove the force, it bounces back to its original straight line shape. If it is very loose, now if I deform it, it comes back faster or slower? Slower. So when it comes back slowly, the elasticity has become more or less? Less. So speed of the sound wave, what do you think will happen? Will it be faster with more elastic medium or slower with more elastic medium?
Faster with more elastic.
Exactly, your intuition is correct. So if it's very tightly stretched, that means the tension force in the string is high. Last one. So now the tension force in the string is high. So elasticity is more. So elasticity is more, the speed of the wave or disturbance through that medium will be higher. So you can write down the formula also. Velocity is actually root of elasticity by inertia.
So what's inertia?
I'm coming one by one, I told you, right? Now I finished elasticity. So this is elasticity. And this is inertia. So elasticity is a measure of measure of how quickly. Okay, inertia is basically the mass of the particle of the medium. If the please be quiet for one more minute. If the particles of the medium are very heavy, is it easy to move them or difficult to move them? So any disturbance will find it more difficult to make the particles of the medium to vibrate if they are very heavy. So the wave disturbance will travel slower through a heavier medium.
So why root of E by?
Why? It's an empirical thing. If you measure it, it comes out like this. Okay? So less CT, if it's more, the velocity increases according to root of that. It's an empirical formula. That means by experiment we find it like that.
Why?
By experiment.
So does this apply to